Okay, so lots of times when we're talking about big, huge distances in space, we don't we use something called an AU, an astronomical unit. And 1 AU is just the distance from the center of the Earth to the center of the Sun. So in question 14, when it says 5 times 10 to the ninth AUs, it's just giving you the radius. But look at how huge it is. What is that? 7.45 times 10 to the 20th meters. So because it's so huge, a lot of astronomers will talk in the terms of how much further away is it than we are from the sun, just to give them that feel. So this question wants the mass, and it gives us the speed and it gives us the radius. So the easiest way to find the mass would be to use your v squared is equal to g, mass of the central body, over r, and rearrange for mass. So mass will be equal to r v squared over g. So the r we just found at 7.45 times 10 to the 20th. The v squared, they gave us the v up top. You just have to change it to meters per second. So 2 times 10 to the 5th meters per second. Don't forget to square it. And then over 6.673 to the negative 11 Newton meters squared per kilogram squared. Mass is equal to, and when you do this, you should get 4.4658 times 10 to the 41 kilograms. Okay? Now you do have another option. You could have used the V and the R and found period. V is equal to 2 pi R over T. And then once you found the period, then you could have gone to G, mass of the central body, over 4 pi squared is equal to R cubed over T squared. It will give you a number pretty close to this. This one's one step, but you could still go this route. Okay? All right, those are your homework questions. I just want to take a second and talk about your lab, just because we didn't talk about it yet, and tomorrow we'll talk about sources of error. But I wanted to talk about the graph because you might have time today to do the graph. And I'm thinking, can we say the lab due on Friday? Like, hopefully you have the procedure and everything written up, and maybe just the sources of error and maybe the graph left to do. So it says to complete your table. So time for 30 revolutions, divide by 30 to get the time for one. Centripetal force is just going to be the number of washers times the mass of one washer times G, 9.81. And then you should be able to find your speed, 2 pi R over T. R is the 0.50 for the 50 centimeters, and T is the time for one revolution. Okay? And then the last column is V squared. So you're going to take that V and square it. So it says calculate the speed for each trial, square this value, and plot it in a graph of F versus V squared. So you're going to do this guy versus this guy. Okay, so F versus V squared. And whenever they say one versus another, the first always goes on the y-axis and the second on the x-axis. Okay, so if we think about it, F is equal to mv squared over r. So F is your y, and v squared is your x. And remember, the equation is y equals mx plus b. There is no plus b here, so it should go through your origin. And so what's your slope? If you look, question 1 says calculate the slope of the graph. So you're going to do what's called the best fit line. So if you have points that look like this, you're going to take your ruler and you're going to draw a straight line that is as close to as many of them as possible. And if you end up with one dude way down here, ignore that dude, okay? He's wrong. So the best fit line is going to show you, when you graph it like this, which ones you can ignore. And with, like, it's kind of like doing an average, but it's ignoring the ones that, you know, someone fell asleep with the stopwatch, or the circle wasn't that horizontal. It's allowing us to see the best average, okay? So then Once you draw this straight line, it wants you to calculate the slope of it. And when you calculate the slope, you have to pick 2 points that are on the line. They don't have to be 2 of your data points, but they have to be 2 points that are honest to goodness on the line, because then that'll give you the slope of the line. If you pick 2 of your data points and they're not on the line, like these two, it's not going to give you the slope of the line because they're not on the line. So pick 2 points on the line, find your slope. Then it says, pardon me, what does the slope represent? Somewhere here I have a red pen. So if f is y and v squared is x, and there's no intercept, then what is this slope? Look at your equation up here. What is this slope? Okay? And once you figure that out, then it wants you to calculate the mass of the stopper that you're swinging from that slope. So you have the slope, you see what it represents, calculate the mass of the stopper. Once you do that, even though I didn't say it in the lab and I should have, use the mass of the stopper that we weighed the other day and find your percentage error and see how close you are. Okay? So try this, and if you need to ask questions about it, if you don't get it, I can re-say it tomorrow, but hopefully that makes sense. All right, I'll do one video of the seasons, and then your homework is going to be on the sheet that you got either Friday or yesterday, the universal gravitational questions. How about numbers 1 to 5? It's just more like the ones that you did for today, but hopefully this time they're easier. Okay, thank you. Enjoy your day, and watch the next video.